Rational exponents. Rational is a fancy way of saying fraction. So what we're going to have here is we're going to have exponents that are fractions. 9 to the 1/2. Well, I don't know what that is. But I know if I take 9 to the 1/2 and I square it, I would multiply my exponents. 1/2 times 2 is 1. I would get 9. In other words, 9 to the 1/2 is the same as something, and when I take that something, I square it, I get 9 back. Well, that's 3. Another fancy way of saying all this stuff is that 9 to the 1/2 turns out to be exactly the same as the square root of 9. I could do the same thing with 8 to the 1/3. 8 to the 1/3, I could cube it. When I multiply my powers, I get 1, so I get 8. So in other words, 8 to the 1/3 is something. And when I take that something and I cube it, I happen to get 8 back. The easier way to say that is 8 to the 1/3 turns out to be the cube root of 8, and the cube root of 8 is 2. All right, remember our long list of rules? We're ready for the last two almost. Rule number 11 is if you have a base and you have a fractional power, a fractional power is a fancy way of writing a root. So if you have a 1/3, it's a cube root. If you have a 1/5, it's a fifth root. All right, and then our very last rule, 9 to the 3/2. I could use my multiplication property and I could say that's 9 to the 1/2 times 3. Because think of 3 as being 3 over 1, you would multiply tops, multiply bottoms. Well, I could then go ahead to say that's 9 to the 1/2 cubed. Because this is one of our rules. If I have a power followed by another power, that's the same as multiplying my powers. So notice what's happening here. The 2 from our previous rule becomes the 2 on bottom. That means we have a power of 1/2. So that's a square root. And then the number on top, the 3, becomes your power. Square root of 9 is 3, and 3 cubed is 27. All right, same thing happens here. What happens is the number on bottom becomes our root. So 8 to the 5/3 says we're doing the cube root of 8, and then we're doing a power of 5. Cube root of 8 happens to be 2. That's 2 to the 5th, 32. All right, so there's our very last rule. Our very last rule says if we have a base and we have a power that's a fraction, then what happens is the thing that's on bottom, that becomes your root, and the thing on top is your exponent. That's all our rules, 12 of them. Okay, let's simplify. Well, going back to what we did before, we know that when we multiply two things, we should add our powers. What's not fun is now we have fractions. So we have to do 1/3 plus 2/5. Well, you know what? That's what these things are for. 1/3 plus 2/5, and give me the answer as a fraction. So that's b to the 11/15 divided by b to the 3/8. And now I know when I divide two things, I subtract my fractions. Subtract 3/8 and give me the answer as a fraction. What a nice number, 43 over 120. So that's b to the 43 over 120. All right, so these fractions look crazy. It looks like there's all sorts of new things. There really isn't. It's really the same rules. When we're multiplying, we add fractions. When we're dividing, we subtract fractions. The deal is they're fractions, so we're going to use our calculator. This problem, we've got pretty much the same rules. We've got things with negative exponents, so we move them. So this is going to be the c to the 3/4 does not move. the b to the 2/3 does move. And then this one, the b to the 1/2 does not move. The c to the 1/3 does move. Now I notice I have b's on top and b's on bottom. I subtract my powers. 1/2 minus 2/3. Give me the answer as a fraction, please. Oh, you can't see what I did there. There it is. I get b to the negative 1/6. And then my c's, I do 3/4 minus 1/3 fraction 13/12. Finally, I recognize the b has a negative exponent. It moves. C to the 13/12 divided by b to the 1/6. Again, all the same rules we had in the previous section. It's just now we're dealing with negative numbers and we're dealing with fractions. Fractions, we use our calculator to do the adding, subtracting. Negatives, we move them. That's all. All right, last two problems. Again, looks gruesome, looks scary. Break it into tiny steps. The last thing we're going to do is that power out there. We're going to do all the simplifying inside first. 24 divided by 3, that's 8. And then I'm going to move things. I see I have some negative exponents. B to the 16. C to the 1 goes down to the bottom. The 3 I already dealt with because I did 24 divided by 3. That gave me 8. There's a negative exponent, so it moves up to the top. There's a positive exponent. It does not move. Okay. Continue to work inside my brackets. 8. 16 plus 2 is 18. And c to the 3. And then I have this negative 1/3 power. All right, without the negative here, I would know what to do. Without the negative, this would tell me cube root. Cube root of 8 is 2. Without the negative, I would multiply these powers. 18 times 1/3 would give me a 6, and 3 times 1/3 would give me a 1. So without the negative, I would have a 2, a b to the 6th, and a c to the 1. So what's this negative going to do? Well, this negative is going to go in and hit all of these also. So what's this negative going to do? It's going to flip the whole fraction. So if you have a negative out here as a power, it flips everything. So that's c cubed, 8b to the 18, and then you have a 1/3. So we could have written that as a rule, I suppose. Maybe that could be rule 13. But that's what happens. If you have a negative power outside a bracket, it flips everything, because that negative is going to distribute to all the pieces. Multiply, 3 times 1/3 is 1. Cube root of 8 is 2. Multiply 18 times 1/3 is 6. All right, last one. Again, these things look really gruesome. Again, split them into little steps. Now notice this time we've got this parenthesis with an exponent. There's nothing I can do inside this parenthesis, so I have to deal with this exponent first. 8 to the 1/3. That means cube root of 8. Cube root of 8 is 2. B to the 3 to the 1/3. I multiply my powers. 3 times 1/3 is 1. I didn't write the 1, I guess. C squared to the 1/3. I multiply my powers. 1/3 times 2 is 2/3. And then we've got to do the same thing down on the bottom. I've got this parenthesis, and I've got this exponent. Not much I can do. Now, you might be tempted to move this negative 2. You can't move this negative 2 because it's trapped inside this parenthesis. So I'm going to have to deal with getting rid of this parenthesis and then move it. 81 to the 3/4. I'm going to go off to the side here. 81 to the 3/4. That would mean do the 4th root of 81 and then cube it. Turns out the 4th root of 81 is 3. Check it out. 3 times 3 times 3 times 3. Just try that. You'll find that you get 81. 3 cubed turns out to be 27. Rats, that's what I write a 3 again. 27. All right, here I multiply my powers. Negative 2 times 3/4 is negative 3/2. And if you're not comfortable with that, use your calculator. Take negative 2 times 3/4 and work it out. 8 times 3/4. Again, if you're not comfortable with that, that turns out to be c to the 6th. All right, so here's what I see now. I'm going to have 2, b to the 1, c to the 2/3. None of that moves. I'm going to have a 27 on bottom. This b right here, this one's going to move. b to the 3/2, and then c to the 6. I'm going to have the 2 on top and the 27 on bottom. Those don't reduce at all. My b's, 1 plus 3/2 turns out to be 5/2. And my c's, 2/3 minus 6, turns out to be negative 16/3. All right, I have one last step. The one last step is negative exponent drops to the bottom. So final answer, 2b to the 5/2 divided by 27c to the 16/3. All right, so final conclusion. Not an easy problem, not by any means. Break it down step by step, following the order of operations, and use the rules, and you should be okay. Lots of little steps, lots of places where you could make a simple little mistake. If you make a simple little mistake, that's not going to be a big deal on a quiz or a test, so don't worry about it too much. But follow the rules carefully. Try to get the right answer. Even this one up above required quite a few steps. But again, follow the order of operations. Do inside the brackets first. Stay inside the brackets. And then finally deal with this exponent on the outside. This is probably the toughest section up to this point. Don't be surprised if you have to spend a little extra time on it, work a little extra hard. Send me some extra emails asking for help.